Welcome to the video lecture. Today I am going to explain about Lorentz force equation. Lorentz is whenever a charged particle placed in a magnetic field as well as an electric field, it experiences some mechanical force. That mechanical force is equal to, here I am writing here, F is equal to charged particle placed in both electrical field and magnetic field, this small moment. In SI units it is called the newtons. For example, here only electrical field is available at that means B is absent. Magnetic flux density at the time the F is equal to QE. Here B is absent. This is the equation for electric field alone. If the particle is available only magnetic field, that means electrical field is absent. At the time the value equal to Q V cross B newtons. So according to right hand rule, here the force is always perpendicular to the both charged particle and magnetic field. So this is simply can write it as B V Q sin theta. Here theta is the angle between the both particle and magnetic field. So newtons. Similarly, this is the equation F is equal to, from the magnetic field, you know this B V Q sin theta. From that one you can easily say that you take a current carrying conductor, it have some length, at the time we can read it as, in terms of any current carrying conductor placed at a magnetic field, it experiences the mechanical force. But how it is, simply you can remodify it here. B or V is nothing but we have some meter per second, can tell length of the conductor some L in meters, take time in seconds, and Q sin theta. Yes, I rewrite is this already B L remodified Q by S sin theta. We already know charge per unit time is called as a current. So charge per seconds is nothing but a current, that's why you can rewrite as it is called as a BIL sin theta. Here I is nothing but the Q by S. So charge per unit time is called as current in newtons. So I can conclude, so this equation says that whenever a conductor, it carries some current, that means current carrying conductor placed at a magnetic field, it experiences the mechanical force. So I read it as here the sum of the terms I used generally. Charge is always measured in coulombs and E is in voltage per meter, and B is the flux density, here is the electrical field intensity in volts per meter, and B in actually Weber per meter square, are simply called as Tesla, and V is already velocity of the particle in meter per second, or simply velocity. So here the force is here already measured in newtons. I conclude that Lorentz says that whenever a charged particle placed at a magnetic field as well as electric field are combined, it experiences a mechanical force. The combination of both electric field and magnetic field at that time, the force equal to Q into E plus V cross B newtons. So, individually, for example, only the particle is available in the electric field at that time is equal to QE. The particle is available only magnetic field at the time, the force equation is equal to Q into V cross B, that is called as a BVQ sin theta. And not only that, I extended this equation for the current carrying conductor. In this current carrying conductor, in every current carrying conductor placed at a magnetic field, it experiences the mechanical force. Thank you.